Here's a new project then, and this is actually the final unit, unassuming little black box here. And we've got, if you look on the back, we've got some rubber feet on there. There's a USB charge port, and then there's just a power switch on the side here with a little power LED. And this is actually a Bluetooth audio to medium wave AM converter. So let's go and take a look at this then. So a while back we looked at this old Motorola car radio, and this was for an old classic Daimler car, and of course the owner was keen to keep the radio period for the car, so wanted that repaired. But of course we're seeing that the AM stations are disappearing, and that there's just less and less available, and so the functionality of this kind of radio becomes limited just because of that. And so I was kind of pondering, how do we get around that problem without actually interfering with the radio itself, and keeping it standard. So that's where the idea for this project came about. So of course there's a lot of these old vintage AM radios still around, and there's a bunch of people that do restorations and the like of these old radios. Here's a couple of other YouTubers here, and the problem with the lack of AM stations is only going to get worse and become more problematic. And there's a few ways to get around that. We could add some line inputs to our radios, or radiogram, maybe more suitable for that kind of thing. And that's obviously going to give us good fidelity. We could add FM radio modules or Bluetooth modules to the radio itself as well. That's another thing you see commonly done. But however, that takes away from the originality, and each radio would require some modification. And so another answer is you maybe have a short range AM transmitter that maybe covers the room or around your house, etc. And Mr. Caldera here, this video here is a little project he done, and there's some good references in here. And this was the deal here, is a little a house transmitter that you could pick up around the house. That's not so easy for a car, however, and again, you've got sort of, to do that properly, you need big antennas and the like. So I was looking for something a little more self-contained that could perhaps go in the car, or the like. So this led me to the idea of having just a Bluetooth audio to AM converter. And first I'd done a search online, to see if something was available that actually did this thing. This is the sort of thing you might expect to find on AliExpress or eBay or the like. But I couldn't find anything that did this functionality actually. So we set about coming up with something ourselves. And we really want this just to be a self-contained box that's there's no control of it really once it's all set up, and it should just receive our Bluetooth audio and spit out AM that we can receive on our radio. And the deal is, this is meant to be short range. It's only maybe covers a few meters of range, and we're not transmitting. We're not covering any sort of area. And this is it's more a magnetic coupling that we're doing into our radio here, so it's meant to be very short range. And the idea is that you would just locate this little box somewhere near the radio of interest, or you could hopefully just put this in a car, if that was what you were doing. It could be, we could connect it to the radio's antenna, or put an antenna on it if we wanted longer range. There's nothing to stop us doing that. That just wasn't the intention here. We could also, as opposed to Bluetooth, we could feed line level input, or feed the input from an FM radio or the like, and do the same thing. But this is what we're kind of going to explore here at the moment. So what's inside this box then? And you've got a few different sections here. We've obviously got some power supply and batteries, etc. They're kind of standard stuff that we'd expect anyway. And then we've got these little modules, and you do find these in AliExpress, very cheap Bluetooth modules that just you can connect to your phone or whatever very readily, and it just spits out audio from there. So that's kind of the basic building block of this thing. and we need a little bit of gain just because of the levels from that guy. So we've got a little amplifier here just to up the gain, and then we've got an AM modulator, so we're just taking our audio and modulating a carrier to give us our AM. And of course we need an oscillator to give us that carrier here, so we've got a medium wave band oscillator that also drives that modulator. And then, as I mentioned, we're not looking to put antennas on this thing, we're just looking for a close field coupling kind of idea. So just a magnetic output from the box there that is going to couple into our radio. So that's what's in our box. Let's take a look at the schematic of what we're thinking to do this job then. And of course we need our modulator. The modulator's at the centre of this thing. And we're just going to use a classic long-tailed pair here. And so these two top transistors, they're driven from our oscillator at the RF frequency. And they're just toggling on and off. One's on, the other one's off, and they just sort of alternate continually. And they drive our coil. And we've got an option here for different kinds of coil. We'll explore the different options there next. So that's what the two top transistors are doing. And then in the tail here, we've got this transistor that defines the current through that pair. And if we modulate that current, then we can modulate the amplitude of the output RF on this coil. So that's the deal there. And we modulate the current through that transistor with our audio, and that's coming from, we've got just a single op amp here that's driving that, and that's there just to give us a little bit of gain from our Bluetooth module here. So we've got the audio coming from here through our op amp, giving us a bit of gain. That then modulates the current through this transistor, which in turn modulates the level of the RF that appears on this coil. So that's the deal here. I've got a reference here where I kind of originally came across this, but really it's textbook stuff, standard long tail pair. And we've got our oscillator on the left hand side here. This is a circuit I've used for many years in different forms. It's just quite straightforward and quite reliable, so we'll use that here. And then there's some other power supply stuff that we'll cover later. But this is the schematic of what we're looking at, and this is actually the final schematic. So this is after I've done all my tweaks, etc. But we'll go next and we'll look at the individual sections. We're obviously going to breadboard these sections before we go on and do a board for this thing and the like. So let's look at that. All right, so got a few different coil ideas for this thing here, and I mean the deal is that we don't want an antenna on this unit. I don't want to have long wire antennas or any of that kind of thing. We just want something that's going to couple, close field coupling thing. So it's more a magnetic coupling. So I've got this magnetic loop, if you like, here type coil. It's just a piece of plumber's pipe with the windings on it, and I did my calculations and they then measured that, and we've got about 100 microhenries there that will resonate with a parallel capacitor, and we should get a decent magnetic field from that will couple into a radio. Let's say though that we've got we want to hardwire the unit into a car. Then here's another coil approach. I've got a ferrite core here, again wound up 100 microhenries. And the thinking is, if it's hardwired into the car, we can take the antenna, the existing car antenna, and break into that and take the centre section of the coax that goes to the antenna and just feed that through. So we've got a single turn, and then that will couple into the radio through that way. So that's our second plan. And then finally, I've got a ferrite core here, so it's a bit smaller, and again the 100 microhenries wound on that, and we'll just see how these behave and pick our approach depending on how they perform. This is obviously nice and compact and should fit in our box quite nice, so I'm kind of favouring this idea at the moment, but we'll see how we go. Right, so we've breadboarded the little modulator circuit here, and I'm using the bigger coil here just to try this out, and I've got a couple of turns of wire around there that I'm just picking up on my scope probe. So I've got the scope probe going into channel 1 of the scope here, and then I'm feeding this modulator. We've got our RF carrier coming in from a function generator, and then I've got another function generator giving us our audio here, and we can see we've got really nice AM shown in the scope here. Sometimes actually it's nicer to look at on the old analog scopes, but here we are, and we can obviously change our frequency there, and we can change. Let's look at there's our modulation depth, so we can go right up to 100% or more, and that's all looking good. So we're looking for maybe 40-50% modulation on the AM, and I'm quite happy with what we're looking at there. So that's all good. Next thing we'll go and do, we'll breadboard the oscillator circuit, and then look at that in isolation, and then we'll maybe feed that into this and look at the more complete thing. And this is obviously a bit of a mess, you know. This is how all electronic gadgets start. You know, they don't start in a nice polished enclosure, etc. But you know, we'll prove everything out here, and then we'll put it on a proper PCB and see how that goes. Anyway, let's go and look at our oscillator circuit. Here we are looking at the oscillator section then, and a nice waveform on the scope. I've got a little bit of filtering on the output. The raw output it's not quite as sinusoidal. You can see there, that's the raw output of the oscillator, so it's a bit kind of lumpy, but still, I mean, good enough for the application. But when we do a little bit of attenuation and low pass filtering, we get quite a nice sine wave there. And I'm connected to a frequency counter here as well, so we can see the numbers on that. And I've got a little bit of variation here. I can vary my frequency. Let's go down. So there's the minimum there. So I can go down to about 1.16 megahertz, and on the top side up about 1.4. And I'm not trying to cover the whole AM band here, you know. I'm just looking to have some variation roughly around about the 1.3 megahertz, and we'll just choose a spot there and kind of centre things on that. If we wanted to have the full range, then we'd need a bigger range capacitor, and you know, do something there. And it's all quite possible, but not really necessary for what we're doing here. So quite happy again with how that's performing. What I'm going to do now is we need to make sure this thing's stable over a period of time. You know, there's no point in setting this to a frequency and then it wanders off and drifts away, and then you have to keep retuning your radio. That would be a bit rubbish. So what we'll do is we'll do some logging on the actual frequency here, and we'll look at some graphs of how that behaves over time. Just make ourselves happy that it's not drifting to any degree that's going to be a problem for us. So let's go and set that up, and we'll get some graphs. All right, so I let this thing run for about an hour and a half, and here's the results here. What I did is I took a measurement of frequency every 5 seconds, and then we just ran it over that sort of hour and a half period. And you know, there's obviously a bit of variation here. This is the inflection points are when I leave the room and when I come into the room. And there's maybe, you know, a draft, or the temperature changes slightly, something like that. And of course our board, it's just this breadboard, so everything's open in the air and kind of prone to anything that's going on. So it'll maybe tighten up a little bit when we put it on the proper board. But there's about 60-70 hertz of variation over that time. And that's at our RF frequency. So I think that's more than tight enough for what we need. And you know, good enough to be going on with. And we'll maybe just connect it up to our modulator now and kind of complete that part of the system and see how it behaves. Okay, so our lash up's grown a little bit here. Then we've got our modulator that we saw, and then the oscillator is connected up now. Made a few changes there to lower the output impedance just to help drive the modulator a little bit better. But that's working well now. And then we've added our Bluetooth module, and then we've got our op-amp circuitry here just to give us a little bit of gain and to combine the left and right channels. and then that drives the modulator also. A few other bits and pieces here. We've got, this is a battery from an e-cigarette. We see these things scattered at the side of the road, you know, littered, and you know, they actually contain these very useful lithium batteries. So this is what we're going to use this guy for. We've got a charge circuit here, so we can charge that battery from USB, and then of course that's only sort of 3.7 volts, and we need a bit more to drive our circuitry here. So this little boost regulator circuit takes us up to 12 volts. So this is working fine, and if we power up, we'll see we start to get some LEDs on the Bluetooth module there, and then the solid blue light means it's connected to my phone here. So I've got my phone, and I've got a little sine wave generator here that we can play, a little function generator rather, so we can play a tone, and then the slow flashing light there says yeah, we're connected and we're playing media. And so I can change my frequency, can change my amplitude and things like that. Let's say we can have a wee look at the scope here. I'm still coupled to my coil here, so we can look at the output on the scope just as we vary the levels and frequency on this little function generator app here. So let's just take a look at that waveform. Right, looking at the output on the scope then, I'm using my old analog scope here. Sometimes it's the right answer for these kind of things. It's a much nicer display actually for this. And we're looking at the RF carrier here. So we're up at our 1 point whatever megahertz. Nice clean carrier there, about 2 volts peak to peak. We're sampling off that coil. And if I turn up the volume on my phone, we can start to see the amplitude modulation there. We can start to see that waveform waggle up and down. And then if I drop the time on my scope, then we can see clearly there. There's our modulation, all very nice. So that's looking good. And obviously, you know, what we've got here is a bit of a lash up. It's not something we can take forward. So we'll go and look at doing a proper PCB for this now and see how we get on with that. Alright, so after we spent a bit of time on our sort of lash up breadboards there and tweak that to a point I was happy, then you know the next step is we need to smarten this thing up and get a PCB made for the job, and so that's what we've got here. And on the left hand side we've got some power supply stuff, either the modules that we saw, or if we're powered from 12 volts we might want some discrete stuff in there as well. So there's a few options there. Got our Bluetooth module, and then here's our op amp that's coming from that. This section here is our modulator and all the associated components for that. And then on the right hand side, this section here is the oscillator, and as you can see, I've got this sort of moat around there, and so this area is kind of tightly controlled. It's specifically laid out and tightly controlled, and the reason for that is that, you know, what we're proposing to do here is to create a magnetic field in our coil, and that coil is going to be in close proximity with this circuitry. And so the chances are, you know, we're just going to feed back into the circuitry and give ourselves all sorts of problems. So the deal here is that we can actually put some shielding around that oscillator and, you know, limit any interference from the field that we're actually generating. So that's just, that's there as an option. We might not use it, but we'll see how we go. And it's the same in the back of the board. We've got the option to put a bit of shielding in there. So that's our design, and we'll go and get that made up now and see how we get on from there. So here we are after a bunch of time. We've got our boards back here, and they're looking fine. Quite happy with them. We've obviously got one of the boards loaded up here, and I've just been going through turning this on stage by stage and checking that we're okay and doing a few tweaks along the way. And we can see we've moved to the ferrite core here as well, and I've now got a primary and secondary coil arrangement here. So the primary with much fewer turns is driven by our circuitry, and then the higher turn secondary, we just resonate that with a parallel capacitor here. And this arrangement is just giving me a much higher field strength, and so we can cover a bit of distance quite happily there. And it's working. I've been playing it and using it, and if we power up, you can see our Bluetooth LED here is all working, so quite happy with that. We'll look to get this in the enclosure next. And just to compare, if I go back to my original breadboard kind of lash up here, obviously very messy, and now looking kind of compact and tidy. So let's go ahead, we'll get this in enclosure and see where we go from there. Here we are, everything in the enclosure then, and the board just slots in here. The board was designed for this enclosure. We've got our batteries in here, and the coil is just on the other side of the board here, with just a little bit of cardboard at the moment holding that in place. And when I put it in the enclosure here, I was getting some coupling problems, and I had to install my shield here around the oscillator. So this is a mu metal shield, so that helps us shield the magnetic field of that ferrite coil getting back into our oscillator and causing sort of funny issues there. But that's working well with that shield in place. So that's us. And then on my lid here, I've actually got a little light pipe that picks up on the charge port LEDs, and that was another part salvaged from some of these scrap e-cigarettes that we see lying around. So that's working well, and we'll power it up now and just see how it behaves. Right, we're all complete now, and I'm using this original coil that we used just to pick up the AM here and feed it into the scope, and plenty strong signal here to do that. And you can see if I change the level on my scope on my phone here, we can see the result on the scope, and we can change frequency as well. Let's go up here, single. So that's all working just fine. I think the next thing to do now is we'll play some music and just see how it behaves. Alright, I've got some music here playing, and I don't actually have any sort of vintage radios here. I've got an old Pioneer tuner in the corner that's I've got a loop antenna on that, a couple of meters away, and sounding very nice.
I forsake them all for your sweet kiss. For that's all I'm wishing to be on.
Well, I might be gone.
So this is Phil's 1964 Daimler with a Motorola radio in there.
Sad and lonesome.
Well, I just thought you might want something fine, made of silver.
Lego mansions.